Hello. Today I'm going to show you how to graph the equation f of x equals x times the square root of 2 plus x by using derivatives. Now to do this, there are lots of different steps we need to follow, so I'm going to start labeling them A, B, and C to help tell them apart. So step A, we just basically need to find the domain of the equation. And now since we can see that we have the square root symbol here, we know that what's inside the square root cannot be less than 0. So the lowest number that can possibly be inside the square root would be a -2. Because -2 minus -2 equals 0, square root of 0 is 0, and that works. If there were anything less than -2, we would have a negative number in the square root, and it just won't work out. So the domain is between -2 and infinity, because any positive number will work in this situation. So now we already have the domain. Next step, we have to find the y-intercepts and the x-intercepts. Now for the y-intercept, we can look back at our original equation. We can see that when y equals 0 is whenever x equals 0. So if x were to equal 0, this equation will cancel out into 0, and we will get y equals 0. So y-intercept when y... Sorry about that. Try to keep things neat. When y equals 0. And since x also equaled 0 when y equals 0, we can also put that as an x-intercept. But now looking back at our equation, we can see that if we were to put a -2 in here, we get 2 minus 2 and we'll have a 0 in the square root. So therefore, we also have an x-intercept at x equals -2. Alright? Now that we got our intercepts, we can go to our next part, which is determining whether or not the equation is even or odd. Now it's really easy to see if equation is even or odd. You just see f of -x is equal to f of x, and if f of -x is equal to the negative function of x. Now, you could probably work this out on your own. I'm just kind of speeding things up, but I've already went through the math, and I can say that none of those things apply. So, both of these equations right here do not equal each other. So we can say that our function will not be even or odd. And then there is no symmetry. Alright, now that we get that out of the way, we can go to our next step, step D. Now what step D is to determine if there's an asymptote in the equation. So if we were to look at the original equation, we said earlier that all numbers work except those below -2. Now, if we were to visualize this, say this number was -2 right here, and from that point on in the equation, the line is just going to continue going right. There aren't any vertical asymptotes, there aren't any horizontal asymptotes. There will be a curve later on, but we haven't been able to determine what that is yet. So, all we can say for certain now is that our equation will have no asymptotes. Now moving on to step E, we have to determine where the function is increasing and where it is decreasing. And to do that, we have to find the derivative of said function, because the derivative tells us the slope of the function, and the slope will help us determine where it is increasing and decreasing. So to find the derivative, we take the original equation. Well, okay. So it would be d over dx of x2 plus x. And working that out, we do the multiplication steps. Times 1. We simplify things out. 2 plus x to the negative 1/2. X plus 2 times 2 plus x. And that equals, simplified out, 3x plus 4 over 2 square root of 2 plus x. Okay, so now that we have our derivative, we can finally determine where and when these things will be increasing. So we've already determined a couple important values with our x and y intercepts. But first we're going to have to try to find the value of x by plugging it into our derivative equation. So if f of x, or the derivative of x is 0, then we plug it in, we get 3x plus 4 equals 0. And we're going to simplify that out. We get x equals negative 4 over 3. Now that we worked it out, we can now we have this value, negative 4 over 3. That's going to help us determine certain important points in our graph. So now that we got that, we can make a little bit of a mock graph to help us determine where everything is going to be going. So let's put negative 2 right here. This would be negative 1. Negative 4 over 3 would be right around here. Alright, so if we were to plug in any numbers that are below negative 4 over 3, we would get a negative number, thus meaning that it will be going down. If we were to plug in numbers greater than 1 but less than 0, we would still get negative numbers. But once we go over 0, we're going to start getting positive ones. So that's going to be basically our curve. It's not our curves, but it's basically where the negative values and positive values were going to be. So negative 2 to, well, it's going to be increasing here, but it's still negative. So negative 2 to the negative 3, negative 4 over 3. That's when it's going to be decreasing. And negative 4 over 3 to infinity is increasing. Alright, now that we got that down, we have to figure out if there's a local min and a local max. Now looking at the last step we did, we can tell that there is going to be a local min, which is just going to be when the slope is going to equal 0. But we also know there's going to be no local max because it's just going to keep increasing up into infinity. So we have no local max, and we can find the local min by plugging in the x value we discovered not too long ago, because the local min happens at negative 4 over 3. So we get negative 4 over 3 times the square root of 2/3, because we do the math, and then we get about negative 1.0 something, probably 9. Okay, so now we know that our local min is probably going to be at negative 1.09, and that's good. Now the final step we have to do before we can actually do the graph, I'm actually going to start a new page. Pardon this for a second. Alrighty. We have to find the concavity. Now the concavity is basically whether it has an up U shape or a down U shape when we're drawing it. So to find the concavity, we have to find the second derivative. We already know the first derivative, which was 3x plus 4, that's a bad plus sign, over 2 times 2 plus x. Now if we were to make that into a second derivative, I already did this work off-site, basically just to make this part a little quicker. 3x plus 8 over 4 times 2 plus x to the 3 over 2. Alright, now that we got that, we can determine the concavity basically the same way we determined whether it was increasing or decreasing, except this one is just a bit different. And now, the interesting thing about the concavity is that it's not like the increasing decreasing, because at basically all values we're going to get a positive number. And since we're always going to get a positive number, we're always going to have positive concavity. And if it's a positive concavity, that just means we're going to get a nice little U shape, and it's just going to be a little bit easier for us to actually make our graph. Now that we have finished all the steps, we can actually make our graph. Okay, now looking back, we can remember that we had an x equals 0 over 0 value, well, 0, 0 value, so we can put that one in. We also know that the equation is going to start at negative 2 and go on to infinity. I'm going to put the 2 there and another 2 here just for the sake of it. We also know we're going to have a local min at negative 4 and 3. And let's put a 4 and 3, positive 1. And I think that's all we need. We know it's going to be decreasing when it gets over here, and that's going to be increasing from then on. We also know that it's going to have a basic U shape all the way through. So if we were to do that, we would have to make our local min, which is negative 0.9, pardon me. So we're going to make it go down for the local min, and then we're going to make it go up, go to the 1.9 for the 0.3, and then go on to infinity. It may not be the nicest of all drawn graphs, but that's essentially what the graph of our function is going to be. Now that was a lot of work to get the graph, but it was simple and it helped us. It just basically helped us draw us better. It made us let us know which way to draw the curve, and basically what parts would be decreasing and what parts would be increasing. So that's essentially it. Thank you for watching.